Hi, everyone. My name's Michaela. I'm a PM on VS for Mac and Xamarin Platform, and I am here to tell you why C# is the best language for writing mixed reality applications. So, working on Visual Studio for Mac and C#, clearly C# is my passion, so I may be a little biased, but there are a lot of really great options. And also, mixed reality is super exciting too, so I want to combine these two things. And I'm sure a lot of you have had the chance to check out the various mixed reality booths around. If you haven't, I strongly encourage you to do so. But if you haven't, the summary is that mixed reality is essentially combining virtual reality and the real world both ways. So bringing your app into the real world. For example, apps like Pokemon Go, where you have the little video of the real world that superimposes the creature you're trying to catch onto it, or bring the real world into your app, like bringing people into a virtual space for teleconferencing, for example. And there are a lot of examples that are much more exciting than the ones I just mentioned, and I encourage you to go around and look at them. My focus is C#, and C# loves mixed reality, virtual reality. One of the most popular options for writing VR and mixed reality apps is Unity, which is, of course, C#. And I'm actually super excited that on Visual Studio for Mac, which went GA on Wednesday, we included support for debugging Unity apps on the Mac in Visual Studio for Mac. However, there are also other great options. There are other engines, like Unreal Engine is a great option for virtual reality in particular. That doesn't have C# out of the box, but we have a plugin that we haven't made available yet that allows you to use C# with Unreal Engine. And if you're interested in using that, I'd love to hear more from you. But what I'm here to talk about in particular is OhoSharp, which is a game engine in a NuGet. Now, some of you might be wondering why a game engine why you would use a game engine for an app. But the thing is, if your app is working with virtual reality, or mixed reality, or augmented reality, or any of the various combinations, you need to interact with real spaces. You need to render things in 3D. You need to animate them in 3D. You need to simulate physics, perform pathfinding, all the things that you get in a game engine. So even though you're not writing a game, it gives you the toolkit that you need to write your mixed reality app. And the great thing about OhoSharp is that it is small, it's lightweight. You can bundle it in an existing app. Like you could have a screen on a phone, for example, where you have the screen shows AR, but then you also have the rest of your app. So you could have an app, say, for browsing a catalog, and then when you tap on an item, it gives you an option to visualize that item in your room. And that's not an option you get with other game engines because they kind of take over the entire application. It's also open source. OhoSharp is a C# binding to the open source Oho game engine. And it is a very modern, flexible architecture. It's very well defined, designed. It has all the features you would expect a game engine to have, and yet it's small, self-contained, and comes in a NuGet. Using it is as simple as adding a NuGet reference to your project. And if you're using Visual Studio on Windows, you can also go to the online templates, and we have some templates to create a project with this reference and some sample code and so on. So you can just create a new project, hit run, get started very quickly and easily. One of the really interesting things about OhoSharp is that it gives you a code-first experience. So it's not like other game engines where you start with an editor and like drag things into that space and so on, but you can start by writing code to create a scene and add nodes to that scene and so on. So I'm going to jump straight into the code. Okay, so here is some code for OhoShop, which is in an application called Xamarin Workbooks. Now, if you haven't seen this, it's super cool. I encourage you to check it out. Workbooks runs on Windows and on Mac, and it lets you essentially write code and run it in an editor. So this looks like documentation right here, but in fact, I can click on this and hit run, and now we have imported these usings into our current environment. Now, obviously, importing usings doesn't really do much visible, but if I run this next one here, it actually creates a window. So this was using the Oho simple application class, which just creates a window on desktop, passes it some options, the width and height, and so on. And now we're going to make it a little more interesting. We'll add a node to that. So this is a built-in node, and this node is a wireplane. It's a little hard to see on this screen, but you can just see it up at the back there. So this is just because we want some kind of surface to see our object on. I can actually go and change that color to be a little darker here. So this is actually, you have like a full C# editing experience here. So I can type like new color, and I'll do and then I run that again, and oh wait, that's the wrong direction, that's white. Okay, let's go with and run that again. So as you can see, this is a very so I changed the background color, so the grid is now more visible. So as you can see, this is a great environment for experimenting and iterating and learning how things work, because you can just change things, tweak them, you get the results immediately. You don't have to like recompile your application, redeploy, and so on. So next, I'm going to create a node. So the way that OhoShop works is like game engines in general, you have a scene graph, and your scene graph contains nodes, and those have child nodes. This also uses a component-based architecture, so those nodes themselves contain components which give features to those nodes, such as meshes or physics behaviors or audio, and so on. So here I created a car node, and this is actually a node that has a bunch of children. Obviously, creating this from code would be pretty difficult. So what we did to get this car is that we went and got an asset of a car model and ran it through the Oho asset importer, and that converted it into a mini scene graph of nodes, child nodes with materials, and so on. So we have, for example, an emissive material for the lights, another material for the body, more for the interior, and so on. And then I was able to, that vehicle.xml, which had been exported by the importer, I was able to simply load that, and it created nodes. However, the result is just as if I had created those components, those nodes, just like I did earlier. So let's make this a little more interesting. So this is using fully modern C#. So we have the await operator and so on. So we have this run actions. So for a lot of like more advanced 3D games and so on, you would have an animator wireframe, and then you'd blend animations, and that gives you some great results. But you don't necessarily need things like that for an app. If you just want to simply rotate something a little, or in response to a button press or something, we have a really simple way to do that. So we have these action classes, which were in the actions namespace up there. And so you just call this run actions async on a node and pass it the actions you want to run on it. And so here we have the rotate by action, and we're passing it some parameters. You can see in the parameter information there. So we're giving it a duration of 1 second, and it is rotating by 35 degrees on the y-axis, which is that way. And when I run it, we'll see it takes 1 second to rotate 35 degrees on the y-axis. And that's a task, so you can await them, you can wait all on a bunch of tasks. You can use this to write your nice async methods, and so on. So next we're just going to add a little helper method to show you how you can actually add things like text into this scene to label things. So there's this very straightforward thing. We create a text object, and we simply set its color, its font, and we add it as a child to the root node. So the scene actually has a root node, and so the car is a child node of the root node, and so we're going to add it as another child node of the root node. And running that doesn't do much because there isn't any text in the label. However, next we add an event to the app's input that whenever the mouse moves, it ray casts into the scene, just casts a ray directly into the scene and returns information about whatever node you hit with that ray. So this code actually gives us, so when I run this, there we go. You can see that when I move, so here the ray is hitting the body node, and our event is telling us what the model of that node is, what the material of that node is. This is something that, for our example, is a helper that helps us determine what the various pieces were created when that model was loaded by the asset importer, so that we can actually refer to them from code. But you could use this, for example, for allowing users to hover over a model of a car and see details of what that part is, or maybe show UI that would allow them to see more details. Now, it's a car, so let's make it do what cars do. We will run another quick action. So this is using a link expression to select all of the nodes that have wheel in their name, which is the wheels, not surprisingly, and running an action. And that action we're setting to repeat forever, so we're just giving it this neat effect that just makes it that little bit more tangible, because these mixed reality experiences are all about having something that feels real and tangible to your users. And also open the doors. So if you think in your app, for example, you could have this in a little view, but then you could have button UI around that would allow the user to interact with it. Or in HoloLens, you could have actions that would allow the user to see a car suspended in real space in front of them, then connect these up to actions that would allow them to open the doors themselves. But we're going to do something a little more interesting. Oh, and you might wonder how I knew that those were door 2 and door 4. That is because of the raycast allowed us to just hover over them and see that that these nodes are node door 2 and door 4. But next we're going to do something really cool. So we want to sort of explode the car, and explode the car in a good way, so that you can see how the car is made up. Like, maybe this is an educational app or an app for mechanics that is showing them the details of the interior of how the car works. So we have a for each that selects all of the children of the car node that are not the chassis. And then it runs an action to move them upwards. And it's running this action, it's using an easing action. There's a number of different easings that change the rate at which things so if you want to move something from one place to another, you can just make it move linearly, or you can make it start quickly and slow down, or slow down, speed up, slow down. Those are easings. So we're using the ease back in easing, which just gives it this slightly smoother effect. It's not so jarring. If you just move, it's just like move, and if you ease, it's a little more. It's a better user experience. So we're going to move all of the pieces of the car upwards. And because we did that in a for each, and the for each was awaiting, we do them one by one. So we get that really cool effect. And so here you can see the details of the chassis of the car. And if we go back to the hover, you can see that, yep, that is the chassis node. And you can also do cool things like change the colors. Let's see. I'm running a little short on time right now, but yeah, so set up a really neat. So all of these nodes have materials applied to them. So those materials define how it's rendered, how it reacts to light, the color it has, what textures it uses, and so on. The particular material that we're using for this allows you to set a tint parameter to change that material dynamically. So you can use very advanced material, like you can write your own materials, your own shaders, your own. There's a system called Techniques where you can define materials as a series of different shader passes and inputs and so on. But there's a whole range of built-in techniques, so we're just using one in the box, which is the no texture material, which simply applies a color but has it render, actually react to light sources with a decent shading model. And so we just use that to change the colors. So you can imagine you could have a color picker, for example. Or, for example, you could actually switch out the material using the more advanced API here. So, yes, so that was a very quick whirlwind tour. I hope that showed you how easy it was to start putting objects in scenes and making them do things cool. This wasn't a workbook because it's a great environment to learn and mess around with things, but you can put these in HoloLens as well, and also phone environments like Android Daydream. We have, so Oho Sharp, there is a NuGet called Sharp Reality that you can add to your app, which lets you very easily, it gives you this new stereo application class, which takes care of the of setting up the two viewpoints and rendering it in stereo. So this is actually a HoloLens app. I can't run it because I'm on a Mac, but I can open it and look at it. And you could run this exact same code on a Daydream phone or other devices. So I encourage you to go out and think about how your apps could benefit from mixed reality, what kinds of cool experiences you could create for your users. And I hope Oho is the way you decide to use that, because it's a really great way to do these kind of like application type things from a code first, with a code first experience. We have a lot of really great samples on GitHub. You can also check out the engine source code. We'll be putting this workbook up online. The link's not live just yet, but it will be live later. And yeah, add the NuGet to your app and give it a spin.